Good morning. I am Dr. M. Balaji, Assistant Professor, Department of Chemistry, MITS deemed University, Madanapalle. Today I am going to talk about Birch reduction of arenes. What is Birch reduction of arenes? So let me give you an example. A simple benzene ring. So what are the reagents we are going to use for Birch reduction? Lithium or sodium metal in liquid ammonia. Along with ethanol. This is a simple Birch reduction of aromatic hydrocarbon. Just simple benzene ring. The reagents we use are lithium in liquid ammonia along with the solvent ethanol. So you can see the reduced compound you can see here. So how it works? So let me give you a detailed mechanism. Lithium metal. This reaction is fast. When you dissolve lithium in liquid ammonia, so you will get lithium plus and solvated electrons. This will have blue color, blue solution. And then what will happen again? NH3 plus electron. It gives again this is very slow. It gives NH2 minus plus half H2. So blue color means solvated electrons. Let me explain mechanism with the benzene. What will happen? This is solvated electrons, very important to reduce a benzene ring. What we will have? You will have radical anion. Radical anion. And then it will pick up electrons. Negative electrons, can you see here? This one will pick up protons from ethanol. So now you will have only radical. So this will give a side product as lithium ethoxide. This is simple. So please keep in mind that still it's a radical. So what will happen again? Solvated electrons you will have an intermediate. It abstracts a proton from the solvent ethanol. This final product. Now I'm going to talk about what about if an electron withdrawing or electron donating substituent is present on the ring. Assume benzene ring having an electron withdrawing substituent such as carboxylic acid group. As we know, COOH is an electron withdrawing substituent. Sodium or lithium in liquid ammonia. So what we would get? COO, Na. So we have to notice that whenever the electron withdrawing group is present on the benzene ring, the proton abstraction will take place at ipso. This one is ipso substitution and this one is para substituent. The proton abstraction will take place at ipso and para position. Okay. How about the mechanism? So electron withdrawing substituents promote ipso and para for Birch reduction. So what is the mechanism? radical anion. So here you can see electrons are present. Proton abstraction will take place first here. Next, at ipso position. Okay, this is for the mechanism when the electron withdrawing substituent is present on the benzene ring. Now, let's look at what will happen if an electron donating substituent is present on the benzene ring. Let us take an example of anisole. As we know, the methoxy group is an electron donating substituent. So what I mentioned before, if an electron withdrawing substituent is present on the benzene ring, it promotes proton abstraction at ipso and para position. Whereas if an electron donating substituent is present on the benzene ring, it promotes proton abstractions at ortho and meta positions. Here also radical ion is present. Again, proton abstraction will take place. So now you can see when an electron donating substituent is present on the benzene ring, proton abstraction will take place at ortho and para positions. Suppose what will happen if you add a little bit of a small amount of acid catalyst. Small amount of acid catalyst, what will happen? So you will have a conjugated diene. If you don't add H plus also, okay, you will get a conjugated diene as a side product along with the main product with 20%. So conjugated diene, you will get 20% along with the main product of proton abstracted product. Suppose if you want to synthesize conjugated diene alone, then you need to add H plus acid catalyst. But in case of with other substituents, suppose let me take an example of substituted aniline N, N dimethyl aniline. If you perform Birch reduction, sodium in liquid ammonia and ethanol, you will directly get conjugated diene as your product without adding acid catalyst. You will not get this product when you have N, N dimethyl aniline as your starting material. So you will get conjugated diene. But when you use anisole as your starting material, okay, if you want to get conjugated diene, you need to add H plus. If you don't add H plus ion also, maybe if you don't add acid catalyst also, you will get this one 20% along with the main product. But in the case of N, N dimethyl aniline, if you don't add acid also, you will get conjugated diene as your main product. You cannot see this is the product. You cannot get this one as product. So Birch reduction can also be performed with alkynes. So Birch reduction works for alkynes too. Alkyne, sodium, liquid ammonia, you will have E alkene as your product. What would be the mechanism for this one? Same like aromatic ring, you will have radical anion and then ammonia. Here you will have negative charge in sp2 orbital, negative charge in sp2 orbital. This anion, my dear students, this anion prefers to be as E isomer. Now adding ammonia, so you will have the final product. This mechanism follows the same course as the reduction of aromatic rings. So Birch reduction also works for linear alkanes also. Thank you.